Hi friends, welcome to my channel NM Learn My Courses with Nagmani. Today I am going to solve a problem on eigenvalues and eigenvectors, and I will give some tips during solving this problem. So don't skip the video and watch till the end. If you have any doubt, please comment below and please continue the
And if you
video.
see this problem, this is also upper triangular problem. We will see how to find the eigenvalues and eigenvectors for given matrix. Okay, first for finding eigenvalues, we have to write characteristic equation, that is a minus modulus of a minus lambda I, which is equal to 0. This is the characteristic equation for the given matrix. Okay, here A matrix is 1 2 3 0 minus 2 6 0 0 minus 3 and minus lambda into I is nothing but identity matrix 1 0 0 0 1 0 0 0 1, which is equal to 0. Okay, here so modulus of this one, and here a minus lambda I, so 1 minus lambda into 1 1, so 2 3 0, here minus 2 minus lambda, and here 6 0 0 minus 3 minus lambda, which is equal to 0. Sorry, equal to 0. Okay, here 1 minus lambda into minus 2 minus lambda into minus 3 minus lambda minus 0 into 6 0 minus 2 into here 0 into something 0 minus, if you close this row and this column, we get 0 into something 0 minus 0 into 6 0 plus 3 into here, if you close this column and this row, we'll get 0 into 0 0 minus 0 into something 0. Okay, okay, which is equal to 0. If you calculate this, here 1 minus lambda into this one, so 1 minus lambda into minus 2 minus lambda minus 3 minus lambda, 1 minus lambda into 0 0, so here minus 2 into 0 minus 0 is 0, so 0 into something 0 0 minus 0 0 0 into something 0, so these two terms get cancelled, so here this thing is remaining, so from this here we can write that lambda equal to, here we can take minus common, here also minus common, so here 1 minus minus, so minus into minus plus, so we can write this equation as 1 minus lambda into, if you take minus common, then 2 plus lambda, here 3 plus lambda, which is equal to 0. From this equation we can write lambda equal to 1, lambda equal to minus 2, here lambda equal to minus 3. These are the eigenvalues for a given matrix. And if I want to say one trick, that here this is the upper triangular matrix now. So for a upper triangular matrix or lower triangular matrix or diagonal matrix, for any upper triangular or lower triangular or diagonal matrix, for these three matrices, the eigenvalues are the whatever the principal diagonal elements are there, that are the eigenvalues. So here 1 minus 2 minus 3 are the principal diagonal elements. These are the eigenvalues for the given matrix. These, if you see these are the this is one of the property for the eigenvalues and eigenvectors. So this is the upper triangular. For this, the principal diagonal elements are the eigenvalues for the upper triangular matrix. So 1 minus 2 minus 3. So we also got lambda equal to 1 minus 2 minus 3. From this we can verify that whether we got the correct eigenvalues or not. Okay, Next we have to find the eigenvectors. Now here I wrote the given matrix A and the eigenvalues. And from here we know that the eigenvalues are 1, -2, -3. So for a eigenvalue lambda equal to 1, we have to find the eigenvectors. We know the equation to find the eigenvector, that is A minus lambda I into x bar, which is equal to 0. So here A is this matrix, so I am directly writing A minus lambda I matrix here. Okay, see, 1 minus lambda 2, 3, so here 0, -2 minus lambda, here 6, 0, 0, -3 minus lambda. So identity matrix means only the diagonal elements are present now. So directly only diagonal elements will be changed and other numbers will be same. So I am writing like this, and here x bar is the x, y, z. We can assume like that x1, x2, x3 also. So now I am here assuming x, y, z as the x bar vector. Okay. From this equation here we know that lambda equal to 1. After substituting lambda equal to 1, we will see. Okay. Here 1 minus 1, 0, 2, 3. So 0, -2 minus 1, -3, 6, 0, 0. -3 minus 1 minus 4, okay, into x, y, z, which is equal to 0. From here we can write that 2x into 0, 0, plus 2y plus 3z, which is equal to 0. This is the one equation we got. And also here 0 into x, 0, minus 3y plus 6z, which is equal to 0, and x into 0, 0, 0 into y, 0, and minus 4z equal to 0. So from this equation we got the z equal to 0. By substituting z equal to 0 into this equation, we get any one of these equation, we get y equal to 0. And also we don't know the x value now. So we are assuming x equal to k1. Okay, so we can write the eigenvectors is, for the lambda equal to 1, the eigenvector is, okay, the eigenvector is, know that x, y, z, which is equal to k1, y is 0, z is 0. So by taking k1 as common, we can write that 1, 0, 0. This is the eigenvector for the lambda equal to 1. And in comments I am observing that why you are taking k1, k2, k3 like that. So I can say that here the eigenvalues are limited, that if we take n by n matrix, then the eigenvalues for these matrices, n possible eigenvectors are eigenvalues are possible, and there is infinite number of eigenvectors will present for the given single eigen value. So I am taking k1. Here k1 should be 1, 2, 3, any value. So for the lambda equal to 1 eigenvalue, for this eigenvalue there are an infinite number of eigenvectors. So based on this k1 value only, that eigenvectors will be dependent. So we can write like this also. This is the correct procedure to find the eigenvectors for a given eigenvalue. So for lambda equal to 1, we can find the eigenvectors for the lambda equal to -2. So same formula here also, a minus lambda I into x bar, which is equal to 0. So a matrix I wrote here, okay, a minus lambda into x bar. So directly I am writing here. So 1 minus lambda -2 na. So 1 minus 2 is -1. Here 2, 3, 0, -2, -2. Here we get, sorry, I will write a minus lambda I matrix here. So 1 minus lambda 2, 2, 3, 0 minus 2 minus lambda 6 0 0 minus 3 minus lambda. This is the A minus lambda I matrix. Okay, now I am substituting minus 2 here. So minus into minus plus 2 na. So 1 plus 2 is nothing but 3. So sorry, 3, and here 2 3 is common, and here 0 0, and minus 2 minus of minus plus 2. So minus 2 plus 2 get cancelled, 0, and here 6 0 0, here minus 3 minus of minus plus, so minus 3 plus 2 we get minus 1. Okay, x bar is x y z, which is equal to 0. So from here this equation we can write thus 3 into x 3x plus 2y plus 3z, which is equal to 0. From this equation 0 into x 0 plus 0 into y 0 plus 6 into z 6z, so 0 plus 0 plus 6z, which is equal to 0. Here also 0 into x 0, 0 into y 0, minus z 1 into z minus z, which is equal to 0. From these two equations we can conclude that z is equal to 0. Okay, after substituting z equal to 0 in the above equation, we get 3x plus 2y equal to 0. So we can assume x or y anything which is equal to, so let I am assuming y equal to k2. Okay, so by substituting y equal to k2 in this equation, we get 3x equal to minus 2k2. So from here x equal to minus 2k2 by 3. This is the x value, this is the y value, and here we got the z value. So from these 3 we can write for lambda equal to minus 2, the eigenvector is minus 2k2 by 3, y is k2, and z equal to 0. So this is the eigenvector. By taking k2 as common, here we can write that minus 2 by 3, here 1, here 0. If you like, if you don't want this 3 as denominator, you can take, if you assuming that k2 as 3, then we can get here, or we can take 3 common here. So here 3k2, which is equal to 3k2 into minus 2. Here we are just multiplying with 3. That's it. So here 3, here 3 into 0, 0. So we are getting this much. This is the eigenvector for a given eigenvalue. Okay, this is the actual one. If we assume that k2 as 3, or if let k2 as 3, then 3 into, so k2 as 3, then 3 into minus 2 by 3 we will get minus 2, 3 into 1 3, so 3 into 0 0. This one is the, let k2 equal to 3, then only this eigenvector is possible. We can this k2 value be any value from 1 to infinity. Now I am going to find the eigenvector for lambda equal to minus 3. Okay, here lambda equal to minus 3 we are substituting in A minus lambda I matrix. Okay, here we get 1 minus of minus plus 1 plus 3 4 2 3 0 minus 2 minus of minus plus minus 2 plus 3 will get 1 6 0 0 minus 3 minus of minus plus 3 minus 3 plus 3, which is equal to 0. And here x vector is x y z, which is equal to 0. If you want, you can compare. This is the eigenvector for the lambda equal to minus 2, and here I am finding eigenvector for lambda equal to minus 3. You can compare. So here I am writing, so by multiplying these vectors, matrix 4 into x 4x plus 2 into y 2y plus 3 into z 3z, which is equal to 0, and here 0 into x 0 plus 1 into y plus 6 into z which is equal to 0. Here everything is 0, so here nothing is there. 0 into x 0, 0 into y 0, 0 into z 0 is equal to 0. So nothing, this no need of to write this equation. So from these two equations, we have two equations, three unknowns. So let we are assuming any one of value. So here we are assuming z equal to k3. Okay, z equal to k3. By substituting z equal to k3 in this equation, we will get y equal to minus 6k3. Okay, and we know the z value and y value. We can find x value from this equation. So 4x plus 2 into y is nothing but minus k3 plus 3 into z is nothing but k3, which is equal to 0. And now here 4x minus 6 to the 12k3 plus 3k3 which is equal to 0. 4x which is equal to 9k3. From here x equal to 9k3 by 4. Okay, so we know that x, y, z values. So the eigenvector for the eigenvalue lambda equal to 3 is x is 9k3 by 4, y is minus 6k3, z is k3. So by taking k3 common from this equation, we will get 9 by 4 minus 6 minus 1. This is the eigenvector. So let k3 equal to 4. Then we get 4 into 9 by 4 is nothing but 9. 4 6 is 24 minus 24. So 4 into 1 4. This is the eigenvector for the eigenvalue lambda equal to minus 3. In this way we can find the eigenvectors for the eigenvalues.
And one more thing I want to say, here I assume let k2 equal to 3 and k3 equal to 4. That is only for understanding purpose. You can try it up to here that lambda equal to minus 2. For this eigenvalue, the eigenvector is k2 into minus 2 by 3, 1 0 as the eigenvector. So up to there you can write, and if you have any doubt, please comment below. And this video I am providing for your reference purpose. If you want, you can take the screenshot from this video, and whatever you have doubts, please comment below. I will try to clarify your doubts. And if you like the video, please like, share and subscribe to my channel. And thanks for watching. Thank you.